Here we have question number 2. So let's get back to this use. What is the degree of the leading term of this function? So this is a polynomial function. It's listed out in factors, and so what we're looking for is what's going to be the biggest exponent, what's going to be the exponent on the largest what's the largest power of x. So this is x to the first. This is going to square through. We're going to have to FOIL this out, but it will give us an x squared term. This is an x to the first, and this is a first. So when we're going to multiply all those terms together, and so what we do is we add the exponents. 1 plus 2 is 3, 4, 5. We're going to have an x to the 5th power. The degree and the leading term of this function, so that's going to be x to the 5th. So the degree is 5. Now the leading term, the other parts that's going to happen is, so when we FOIL this, we're going to get x times x. It's going to have a leading coefficient of 1. We have a leading coefficient of 3 here and 2 here. So it's going to be 3 times 2, which is 6, times 1, which is still 6, and then times this 3. 6 times 3 is going to be 18. So that gives us our leading coefficient. So as a degree of 5 coefficient of 18, and it's positive 18, right? Let me just make sure there's no negatives in, yeah. So, or we could just lift it as 18x to the 5th. What do the degree and the leading term tell you about the end behavior of the function? So that is by understanding the various different patterns. So there's basically two things we look at. We look at the leading coefficient, whether it's positive or negative. So we're looking for a plus or minus type activity. Oops, that's plus or minus. And then we look to the degree, whether it's even or odd. So for this one, we'll focus on the odd, but then I'll also talk about what even might look like. So what the graph is going to look like if we have a positive leading coefficient with an odd exponent is, it's what I call the saguaro cactus sort of thing. We get, let me go with the color change here. We get basically a little something in the middle here. We get maybe multiples, but the end behavior is that it's going to come from negative infinity and it's going to shoot to positive infinity, right? The y values. So what does it tell you about the end behaviors of the function? That I think the notation they used is that the limit as x goes, we'll start with negative infinity. So x is going towards negative infinity this way, which means the y is going to negative infinity, is negative infinity, and the limit as x goes towards positive infinity is also positive infinity. Now the difference, I guess give myself a little bit more room, if this had been negative, had it been negative 18, because you want to look at all the options, right? The test is not just going to give you exactly the same coefficients. It might give you the negative one. So what happens if it was negative? Well, then it's really just the opposite, right? So when x goes towards negative infinity, the function comes down. Let's see if I can draw this just as well, something like that. It does the same sort of behavior, but it's flipped over. So as x goes to negative infinity, y is actually going to positive infinity in this case. That's the way I learned to make infinity signs is I would write 8 and then I turn it sideways, or I turn the paper sideways and write an 8. Let me put it that way. And as x goes towards positive infinity, y would go towards negative infinity. Now the other part is if this had been an even function, we're different. Let's see. Go here. Had it been even, evens are U-shaped. So a positive U-shape would go like this, positive even, and a negative negative leading coefficient, so had it been negative 18, then we would have got a graph that looks like something like that. And again, the middle part may be funky or something else, but in behavior is, if it's even, they will both go to either negative infinity or positive infinity, depending upon that leading coefficient. Okay, so that's our answer to B. We're asked to compute the roots of the function. So the roots of the function is when the y value equals 0. So when the function equals 0, and since they've given it to us in this factored form, it's actually going to make it easier. So we set each of these terms individually equal to 0. And then we go from there. So what are the roots? Well, we get 3x equals 0. Divide both sides by 3, we're going to get x equals 0. So 0 is one of the roots. Again, we could list them by just listing. X minus 2, now the fact that it's squared is not important, we just need this inside to become 0. So we set x minus 2 equals 0. Add 2 to both sides, so you're going to see x equals 2 is another root. So the roots are, you're going to start to see is the opposite sign that's here. So this is this just going to be negative 9? Well, not quite. We have to do 3x plus 9 equals 0. So yes, we will subtract 9, but then we will divide by 3, right? So that one's a little more involved. We'll maybe do it over here. Let's change color so we know what we're doing. 3x plus 9 equals 0. We will subtract 9 from both sides. And then we'll divide both sides by 3. So we're going to get x equals negative 9/3, which reduces down to negative 3. 9 divided by 3 is 3, so negative 3 is another one. And then the last one we're going to get from here, 2x minus 4 equals 0. So we add 14 to both sides. You get 2x equals positive 14. Divide by 2, you're going to get x equals 7. So we get another one here at 7. So these are the roots of the function. Compute what x as x goes in infinity, what is f of x, and the limit as x goes to negative infinity of f of x. They've actually already asked that, didn't they? They asked what the end behavior of the function is, so that's going to tell us. And we saw as x goes towards positive infinity, since we have a positive leading coefficient and an odd exponent, that as x goes to positive infinity, the y value is going to go to positive infinity. So I'm just going to write it underneath here. I'm going to emphasize it with a plus here. Okay, as x goes to negative infinity, that's this way as we talked about, right? Y is going down to negative infinity. So just different ways of, and again, I use the notation that I see they seem to use. Explains what happens to the behavior of the function if we change 3x to minus 3x. Well, we've already talked about that. Then that would give us a negative 18, and we would flip. Okay, that our end behavior would change. So we've answered that. Then as x goes to negative infinity, y is going to go to positive infinity. As x goes to positive infinity, y is going to go to negative infinity. That's the change. I'll just put C negative coefficient. Explanation. What happens to the behavior of the function? We remove the power 2 on the factor. Well, if we remove the power 2, then it would only be to the 4th power. It would be even, and again, we've talked about that, so maybe I should have just left it off for here, but my way is, okay, there's really just these 4 things we need to look at. Odd functions, behave in these two ways, even functions behave in these two ways. So see even degree explanation. What happens to the behavior of the function if we make both of these changes? And again, we've talked about this. So if we make the leading coefficient negative and we change it to being a positive, an even, then we would be, in this case, down here. So I always just think when things are even, it's kind of easy. Positive, if a positive coefficient makes you smile, because positive things make you smile, hopefully. Negative things makes you kind of frown. So that's a kind of easy one to remember. When it's an odd degree, then it's kind of, to me, it looks like sort of a saguaro cactus with one arm down and one arm up. And you start from down to up because negative goes to negative, positive goes to positive. If it's a negative leading coefficient, then we switch. Negative x's go to positive y, positive x's go to negative y. So that's kind of the way to think our ways through each of these. All right, and that's concept for question 2.